descent periods of a stock. This is pretty much reflective of the stock market as it is right now, especially in the tech sector. It's been nothing but a smooth descent over the last few months. But that's not really relevant to this problem, so let's go ahead and get right into it. So you're given an integer array prices representing the daily price history of a stock. Okay, where price is I is the stock price on the ith day. A smooth descent period of a stock consists of one or more continuous days such that the price on each day is lower than the price on the preceding day by exactly one. The first day of the period is exempted from this rule. Yeah, because the first day isn't one lower than anything, right? What are you going to compare it to? Return the number of smooth descent periods. All right, so we have this stock chart. All right. We have a few days of price action. This stock starts out at price 3 on day 0. I guess I'll call it day 0. They call it day 1, but that's fine. And then it becomes price 2. And then it's price 1. And then it shoots up, rebounds to price 4. All right, so if we connect this stock, we can see what? Let's also look at it as an array. So we have 3, 2, 1, and 4. Like this is 0, 3, 1, 2, 2, 1, 3, 4. Okay, so now when we look at this system, right, this is saying that there are 7 smooth descent periods. So there's the descent period of just 3 alone, right? There's the descent period of just 2 alone, of just 1 alone, and just 4 alone. So that means that a stock day's value is itself just a descent period, okay? Now there's the descent period of 3, 2, right? Because it goes from 3 to 2, like this, right? It goes down 1 on day 0 to day 1. So 3 and 2 alone are a stock period going down. 2 and 1 alone are a stock period going down, right? It goes down from this day to this day. But also 3, 2, and to 1 is a stock period going down. 3, 2 to 1, like this. Right, so there's 7 total examples, right? There's the 4 yellow, there's the 2 blues, and there's the 1 red. So how do we solve this problem going forward? Well, if we were going to look at this array, right, let's imagine that we just looked at each stock period, each day as we encounter the day. So when we encounter, let's have a ledger set equal to 0, all right? And let's also have this idea of the longest day, the longest period we've seen so far. Okay, so maybe we'll do this in here. So we'll have a ledger, longest. Okay, so we have ledger and longest, and then we have 3, 2, 1, 4. So when we look at 3, the longest period we've seen of a smooth descent is just itself, which is 1. And in the ledger, we've seen 1 total stock descent day, right? Because 3 itself is just a 1-day stock descent. When we look at 2, let's put this up because it's getting in the way. When we look at 2, well, 2 is 1 less than 3. So that means that the longest stock descent period we've seen so far is of length 2. When we look at 1, well, it's 1 less than the previous day, and the previous day has length 2. So that means that now we have a longest period of length 3, right? So it's whatever the previous day's longest period is, and we just add 1 to it, right? Because if the previous day has length 2 smooth descent, and the one we're encountering now is also smooth descent, that means that we have a total smooth descent length of longest that's of length 3. And then when we look at day 4, well, 4 is definitely not 1 less than 1, so it restarts as the longest descent of length 1. So how does this longest descent cut into this idea of a ledger? Well, when you encounter 2, right? If you counter any descent like this, right? Imagine you had the descent 5, 4, 3, 2. That would mean that longest is what? It's 1, 2, 3, and 4. When you encounter a 1 here, okay? When you encounter a 1, this 1 can create how many smooth descent periods? Well, for this one, there's a smooth descent period, which is just the 1 itself. There's a smooth descent period where the 2 and the 1 connect. There's a crazy delay. There's a smooth descent period where 3, 2, and 1 connect, right? There's a smooth descent period here. There's a smooth descent period where 4, 3, 2, 1 connect, right? Starting here. And there's an additional smooth descent period where 5, 4, and 3, 2, and 1 connect. So what you can kind of notice is that however long the smooth descent period is, right, in this problem, the smooth descent period is length 4 before you encounter 1. You can attach 1 to each of those systems, right? You can attach 1 to it starting with 5. You can attach 1 to a smooth descent starting with 4. You can attach 1 to a smooth descent period starting with 3. You can attach 1 to a smooth descent starting with 2, and you can attach 1 to itself. All right, so if the longest period is 4, that means that there's 4 cases where you can attach 1 to each of the smooth descent periods in the longest amount, right? So there's a length 4 smooth descent period. That means you can attach 1 to all 4 of the numbers and create a new smooth descent period. And then you can add the one where 1's alone, right? So looking at that through the context of this problem, when you look at 2, right, the longest is 1, so you can attach yourself to 1, or the longest is 1 and it's connected to 3, so you can create 3, 2, but you can also attach yourself alone, so then you can create 2 as well. Right, so up here I'm creating all of the periods that we can create. Right? So that means that the ledger is now 3, right? There's 3 things in this ledger. This was the ledger up here. Okay? And then when I look at 1, well, there's 2 things before 1, so 1 can attach to 3, 2, and then 1, or 1 can attach to just 2, or 1 can attach to just itself, right? So there's 3, 2, and 1, 2, and 1, and 1. So that means I added an additional 3 to this system, so now there's 6. Then when you look at 4, well, since 4 doesn't attach to the previous duration, it can't attach to the 3 that come before, right? I can't do 3, 2, 1, 4, 2, 1, 4, 1, 4, right? It can't consider it, so I have to reset longest, and there's just 1 additional that I get from 4. Right, so whatever the longest period is that comes before me, if I can attach myself to it, I can attach myself to each of the ranges that come before me, right? So that's the general idea of this problem. So let's go ahead and get into it. So we can have this idea of the longest descent we've seen so far, and it's going to be length 1 in the beginning, right? Because it's just the first stock. And then we're going to have our number of descent periods. We'll just call it res, whatever. And then we'll look at each day. Now, we don't need to look at the first day, right? Because the first day has nothing to attach to before it. So there's no point in trying to make a comparison, right? That's why we say res equals 1, because we always know that at least the first day is going to have some information. Now, let's make sure that... Okay, the price of length is always at least 1. So there's always at least one stock. So there's always going to be at least one smooth period of length 1. So we look at each day in range length of prices. But remember, we don't need to look at the 0th day, which is the first day, right? And then we'll say, well, if the price today equals the price of the previous day minus 1, right? So it's the previous day's price minus 1. That means that this is going to be attached to the longest, right? So that means that longest will get updated to be plus equal 1. So we add 1 to longest. And that means that we have enough solutions. We have solutions where we have the current number of solutions plus all the solutions that we get from attaching ourselves to the previous longest, and then an additional solution for just ourselves. Otherwise, well, we get an addition. Longest has to be reset to 1, right? Because we've lost that kind of momentum that we were getting, because we had all these things that were decreasing by 1, and then now, oops, this no longer is decreasing by 1, so longest has to restart. And then, well, you get at least one solution for yourself, right? Because you yourself, just as a single stock price in a day, right, is a valid solution. And then you return res, because res is the number of solutions that we got. Price is not defined. Prices. How pitiful. All right, I'm doing things very wrong here. Oh. Like I said, I need to start at day 1. Right? Because you don't want to compare day 0. All right. That's why I suck at contests, man. All right, cool. So what's the runtime of this? Well, notice we don't create any additional space, right? We just create space for these 2 variables, and we update these variables within the system, right? And we're using prices, which is provided, so it's constant space. So O of 1 for space. In terms of time, well, all we have to do is traverse through the whole prices array once, right? And then make comparisons for each thing. So we have a constant operations within this for loop, and we have to look at each prices. So if we call n the length of prices, then we have O of n in terms of time complexity. And yeah, that's pretty much as good as it gets, right? Because we can't make any assumptions about the data, so that we can't get better than n. We have to look at all the data to know information about the data. So the best you could ever do is O of n. And we got that here. And then for space, we're not creating any additional space. So we have O of 1 space complexity, O of n time complexity. Doesn't get much better than that. I guess the main intuition from this problem is thinking about how many periods, how many continuous smooth descent periods can you create given the number of smooth descent periods that come right before a number that is also a part of that smooth descent period. Okay, guys. Peace.